So at long last, we're finally able to start discussing Java ConditionObject as a class, and we're going to focus on its structure and functionality. And you'll see that there's a lot of interesting things taking place here. So ConditionObject is a class, just like reentrant lock is a class, or just like semaphore is a class, and so on and so forth, that provides the condition variable abstraction to Java programmers. And you can see it's a class, public class, and it implements the condition interface. So again, as always, I highly recommend, if you really want to understand these abstractions, go take a look at the interfaces that characterize what the API does, and you'll see lots of interesting discussions here that will help you understand the big picture about condition objects and conditions and how they compare and contrast with built-in monitor object methods that come out of the Java object class, which is a lower level abstraction that's baked into the Java execution environment, like the Java virtual machine or the Android runtime and so on. Under the hood, condition object is actually stored in a very interesting place. It actually resides as a nested class within the Java abstract queued synchronizer framework. And you're like, what the heck is it doing there? Well, it turns out to be leveraging the abstract queued synchronizer mechanisms very heavily in order to implement the weight sets. So if you take a look, if you were to go look at Java and you were to look at the class diagrams, you'd see abstract queued synchronizer has a nested class, which is called ConditionObject with a whole slew of methods. And ConditionObject is implemented using a linked list of nodes. And this linked list of nodes, you can see it's got it's a doubly linked list. It's got prev and next pointers. This should take you back to CS 2201 in your data structures training, hopefully, that you got here, either here at Vanderbilt or elsewhere. This allows the condition object to have a weight queue of nodes. And that weight queue enables a set of threads, which is typically referred to as the weight set. I'm not sure why they call it a weight set, because it's really a list, but whatever. It allows the weight set of threads to coordinate their interactions by being able to kind of notify and signal each other to make progress when conditions become plausible for progress to be made. And each of the nodes represents a thread that's waiting for its chance to get access to the shared resource that it needs. And this weight set selects the order and the conditions under which a given thread or threads are able to run. As I mentioned before, just to kind of put a fine point on this, a condition object is always, always, always used with a lock, and in Java, it's almost always used with a reentrant lock. There's a few little caveats to that, but let's pretend like they don't exist for the purposes of this discussion, because it's very esoteric when it's not a reentrant lock. This lock protects the shared state in a condition expression from manipulation, from errant manipulation of shared mutable state by other threads. This is just classic reasons of why you use locks. Does anybody know what this is right here? This is Eowyn protecting King Theoden from the Witch King of Angmar and his fell beast on the battlefields of Pelennor Fields. Great scene from Lord of the Rings. She protects, of course, the king is dying, so it's good that she protects him anyway. But anyway, it's protecting something from manipulation by bad forces. Exactly, I am no man. That's right. What a great scene. The way that you get a condition in Java, you could make it yourself, but you never make it yourself. You never say new condition object. You always say new condition, which is a factor method that returns a condition object that can be used with a reentrant lock. So there's a very, very tight coupling inherently and implemented explicitly and intentionally between reentrant lock and condition. That's how you get a new condition object in Java. And we'll see that when we look at the example here shortly. Now, this is a little bit interesting to understand, and I think, I'm one of those people who, obviously, it helps to understand the API because that's what you're programming to. But sometimes when you understand what's happening underneath the hood, the API makes a little bit more sense. And to understand the API for condition object, it helps to understand that it has a queue of waiting threads, just like reentrant lock can have a queue of waiting threads. But they're different queues. Very important to understand. Those two queues are not the same queue. Now, they relate to each other in ways as we'll talk about in a second. Reentrant lock has a queue that keeps track of the threads that are waiting to acquire the lock. Condition object has a queue of threads waiting for some condition or conditions to become true. So they both have queues, but they're queued up waiting for different things. Reentrant lock is waiting for a chance to get exclusive access to some critical section. Condition object has threads that are waiting for some condition to become true, which is a more general concept. And of course, also why you need a reentrant lock in order to check this, because those conditions are typically involving shared mutable state. One of the things that's really cool about condition objects is you can have multiple of them per user-defined Java object or class library-defined Java object, things that are not baked into the Java execution environment like the JVM or ART. And as an example, the array blocking queue in Java can have two conditions, or does have two conditions, not empty and not full. There are two of them, and they both share the same reentrant lock. Very important to understand that. The ability of user-defined classes or Java class library classes, these are not things that are baked into the execution environment, to have more than one condition object enables much more sophisticated and efficient ways to coordinate multiple threads. This will not become clear until we talk about the earlier, somewhat half-baked attempt at this with Java built-in monitor objects, which only had one queue or one condition object per object, per Java object. And why this is important, and again, we will talk about this in much more detail here in just a bit, is it allows having multiple weight sets per application or user object that share a lock allows much more efficient notifications because you don't have to wake all the threads up. You only have to wake up the threads that are waiting for a particular condition to become true. So if you think about threads that are waiting for the array blocking queue to become non-empty versus threads that are waiting for the array blocking queue to become not full, those are two different conditions. And by using two different weight sets or two different condition objects, it allows us to be able to only wake up threads that are waiting for something to become not empty rather than waking all the threads up, which would waste the time of the ones that aren't waiting for them to be waiting for the queue to be not empty. And as I alluded to before, Java's built-in monitor objects, which are older and more limited, can only support one monitor condition per monitor object. There's just a single wait queue. And that is much less efficient, much less sophisticated, much more limited. And we'll talk about that when we get into built-in monitor objects here in just a bit. We'll probably start that on Wednesday. Why that's a problem is because it yields inefficient programs that require excessive notifications through the use of the notify all method. And we'll talk more about what notify all is and why it's a problem. In particular, you end up having to wake everybody up, producer threads, consumer threads. They all have to be awakened every time anything changes in the shared monitor object, like say a simple blocking queue, not an array blocking queue, but a more simple-minded version that I wrote just to show off how this works. You have to wake everybody up, even if there's a whole bunch of them that could never make any progress whatsoever because they're waiting for some totally different condition. So that is the end of the structure and functionality of Java condition object. We will, of course, talk about the key methods. We'll talk about a very specific use case with array blocking queue momentarily.